Так, дорогие коллеги, а сейчас мы услышим доклад, авторами которого являются Пётр Курочинский, Оливер Хаук, Дэниел Дворок. И называется этот доклад «Виртуальный музей утраченного культурного наследия. 3D-документирование, реконструкции и визуализация в семантической паутине».
Dear colleagues, thank you for the invitation to St. Petersburg. I need 20 minutes of your attention to present an ongoing project in its midterm. The German-Polish-Russian project examines the whole process of computer-based hypothetical 3D reconstruction of lost architecture and destroyed interior design. The collaborative web-based research infrastructure ensures scholarly-approved results and stands the requirements of long-term availability and accessibility. The preliminary results are based on the digital 3D reconstruction of two destroyed Baroque palaces, Friedrichstein, now Kamionka in Russia, and Schlodien, now Gładysze in Poland. New findings are concerned with the indexing of sources, documentation, semantic modeling, and visualization of 3D datasets in WebGL technology, introducing the prototype of a virtual museum to the audience. But first, a few words on the background of the research topic. In the context of the rapid technological development, the sluggish implementation of documentation standards, and the common obsolescence of software and hardware, inevitably lead to what one may call a digital elephant's graveyard. Comprehensibility and long-term availability of information, both being essential in academic research contexts, are not ensured in 3D-based reconstruction of cultural heritage. The main scholarly problem is a general problem of a digital revolution. Digital 3D datasets may be difficult to understand unless information about the meaning, so-called metadata, and construction methods like provenance and paradata is provided. A demand for critical computer visualization has been growing for quite some time, and in 2006 it was internationally recognized in the principles of London Charter. By defining the need for paradata, the London Charter introduced to computer visualization an extension to provenance information, stipulating as follows: documentation of the evaluative, analytical, deducative, interpretative, and creative decisions made in the course of computer-based visualization should be disseminated in such a way that the relationship between research source, implicit knowledge, explicit reasoning, and visualization-based outcomes can be understood. The digital hypothetical 3D reconstruction is generally based on two main activities. The activity of a subject expert, for instance an art historian, explores sources and prepares information for computer-based visualization, and the activity of a modeler, for instance an architect, interoperating the sources and creating the born digital 3D objects, the computer-based visualization. The acquisition activity done by subject experts identifies and describes objects for the 3D reconstruction process, like images representing certain objects, for instance the fireplace in the garden hall of a palace in Schlodien. The result of such acquisition activity is a database according all annotated image sources who represent the fireplace in the garden hall throughout the time. The following activity of the modeler is based on the spatial interpretation of the prepared database. The modeler is combining various images in preparation of a 3D reconstruction. The modeling follows the rules of common 3D simulation and animation software. The integral part of the modeler activity is a proper way of protocolling the computer-based reconstruction process. The modeler records the used sources, identifies the level of information, and protocols the interpretation process of achieved level of detail of the 3D model. The protocols contribute transparency in the digital reconstruction. In brief, the project involves the task of identifying sources and the subsequent modeling of the 3D objects. These are the already introduced main actions employed by subject experts and modeler. A web-based content management system in between provides the interface of the annotation, linkage, and storage of the results. Patrimonium.net, the CMS under discussion, includes a domain ontology for digital hypothetical 3D reconstruction. The CMS also generates the semantic database, so-called graph database, and enables the export of 3D datasets to Europeana, as well as the long-term preservation of the information about the 3D objects in a metadata schema called Cultural Heritage Markup Language. The prototype of a virtual museum emerges thanks to the linkage of the graph database to the binary data in the repository, as well as through the subsequent integration of interactive 3D models with the WebGL technology. The integral design feature of a digital documentation of cultural heritage under discussion is the Cultural Heritage Markup Language, CHML. The XML schema of CHML combines the metadata, provenance, and paradata. Authority files and controlled vocabularies are to be implemented. CHML guarantees the certification, interoperability, and long-term preservation of the information contained in digital hypothetical 3D reconstruction. The design of CHML follows the activity-centric workflow of a digital reconstruction and contains 4 main themes: objects, sources, activities, and actors. The action-based methodology employed by the subject expert and modeler of a digital reconstruction corresponds to the event-based character of CDOC-CRM, the conceptual reference model. On the basis of the respective activities, actors, sources, and objects will be described and interlinked. Each record is identified by the uniform resource identifier, additionally labeled by the type system, the semantic core of CHML. The type system, consisting of an alphabetical combination of 4 letters, has to be developed for Baroque art and architecture. The type is the semantic core within the documentation, mandatory for every record. Every term represented by the type has to be translated into English, German, Polish, and Russian, and is connected with controlled vocabularies and authority files where possible. For an improved annotation of the CHML files in the process of computer-based 3D reconstruction, a custom web ontology language, OL, is created on the basis of Erlangen CRM. eCRM, Erlangen CRM, is an application-related interpretation of CDOC-CRM, which establishes a powerful virtual research environment for cultural heritage domains, inter alia in the ongoing WISCI project. The application ontology for hypothetical 3D reconstruction, developed in cooperation with Erlangen-Nuremberg University, is based on the CDOC-CRM reference ontology. It allows the storage of information in the triple architecture of the Resource Description Framework, RDF, with a Sparkle endpoint to ensure linked open data requirements. Let's take a look into Patrimonium.net, the virtual research environment under discussion. You see here the entries of an activity. This is the activity of a reconstruction of a garden house fireplace. You see here all the metadata with linked with get the AAT, Art and Architectural Thesaurus. You see here the title set in German and Polish, the source used, all sources that were used for the 3D reconstruction with the then the results of this activity. This is the 3D model created in this activity. We have all the information about actors, about software, and we have the so-called protocols where the actor, the modeler, and architect is describing what he is doing while he is reconstructing this object. Now we are clicking on the result, and we are jumping into the object entry. This is the object entry for the fireplace in Garden Hall. We see here our type system fireplace with a connection linkage to control vocabularies, the title sets in different languages. Then this fireplace is a part of northwest wall of the Garden Hall, so we are building in a hierarchy. And this fireplace is shown by different sources. At the left we have the object description. This is a free text. And down we have a digital model, so the information about the digital 3D model reconstructed in the process, about the model version, variation, level of detail. And we are also integrating all the objects in the right place in the palace, so they are already located. The WebGL solution allows for the compilation of interactive 3D scenes from repository and the linkage of the 3D objects with the corresponding metadata from graph database, the RDF Triple Store. 3D scenes can be constructed on demand. The virtual research environment thus became a virtual museum par excellence, in which every 3D object is documented in the same fashion as a museum object, and in which visitors or users are offered a tour of the reconstructed Baroque palaces, the respective context included. It is anticipated that the described method of digital reconstruction and the semantic enrichment of 3D datasets doubles the efforts, but seems the price worth paying for creating more than just pretty pictures. It is the price of a scholarly approach and such values as transparency, consistency, certainty, and access in the long term. Here you see the fireplace in the Garden Hall with all objects from our nowadays database. We are in the midterm of the project, and clicking on the objects that are loaded into this virtual museum, you are getting all the metadata from the database. The source is included at the left side. Learn more is the direct linkage into the virtual research environment. So there is an interconnection. Thank you for your attention. Do you have questions?
Thank you so much, Pёtr. And now, colleagues, maybe you have some questions? Yes.
Добрый день, Пётр.
Добрый день.
Вопрос о досрочности хранения данных, именно 3D-данных. Вот в интернете было несколько форматов хранения 3D-данных. Они меняются.
Да.
И когда вы говорите о долгосрочности, используя, например, WebGL и HTML5, так я понимаю, да? Для демонстрации, для отображения, то насколько вы уверены, что эти форматы через 10 лет, например, останутся прежними?
Спасибо за вопрос. Я сразу отвечу и покажу, может быть, слайд, который немножко... Okay. Секундочку. My используем dla записания и сохранения трехмерных данных мы используем сейчас технологию PNG. Так что мы записываем геометрию в картинках. Так что каждая точка, каждая информация по X, Y, Z есть записана в RGB channel in a 2D picture.
То есть вы координаты сохраняете, и коррекция этих координат
не только координаты,
долгое время.
текстуры мы тоже записываем в этом формате. Это сейчас мы сейчас работаем над этой технологией, так что мы записываем сейчас все информации по трехмерной геометрии и материалах в PNG формат. Другая вещь, которую мы сейчас следим, это коллада DAE. Коллада формат – это возможность сейчас записывать информацию по геометрии inline в XML files.
Это замечательно, у вас прекрасная система, но возможно ли восстановление этой информации, например, через 10 лет, если вдруг изменится формат?
Это наша цель, так что мы тоже записываем все мета и параданные, мы записываем в формате RDF и имеем возможность записывать тоже в этом RDF файл весь информацию по геометрии, потому что если мы используем коллада DAE, коллада имеет проблему, потому что размер файлов получается огромный. Но пока это нас не касается, мы думаем, что это просто возможность записывать геометрию на длинный срок.
Да, спасибо. Вы предусмотрели, да, все возможности.
Коллеги, пожалуйста, соблюдайте регламент вопросов и докладов. У нас уже отставание по времени. Спасибо.
Здравствуйте. У меня технический вопрос. Вот если это не секрет, вы используете какое-то промежуточное программное обеспечение для генерации 3D-сцен в WebGL?
Можете повторить последнее предложение?
Да. Промежуточное программное обеспечение. Вот у вас какое-то используется для генерации интерактивных 3D-сцен?
По программированию в WebGL и по интеграции всех данных, это наш сотрудник Даниэль Дворак делает, это его диссертация.
Ну это у вас собственное программное обеспечение, да, без применения каких-то...
Но WebGL может каждый использовать, но он делает, это будет все open source, то, что мы делаем. Так что под конец нашего проекта, через год, все наши алгоритмы, которые он пишет тоже для WebGL, будут опубликованы.
Понятно. Просто суть вопроса была такая, что сейчас же существуют коммерческие какие-то движки, которые генерируют WebGL-сцены, но у вас именно своя собственная программная.
Мы получили деньги из Германии, от Leibniz Association из Берлина. И мы должны были сказать, что мы используем только open source software. И что все наши результаты будут тоже опубликованы в Creative Commons as open source.
Понятно, спасибо. Очень интересный проект.
Ну что ж, коллеги, спасибо. И тогда...
Спасибо.
Следующий доклад...